today we're going to do two things. Some of you have noted that my on-level geometry classes did regular polygons yesterday. They're doing circles today. We're going to do both today. So here with regular polygons, this is a formula that you haven't used before. And you have to know a few terms as well. The center, you know what center means, but the center of a regular polygon has to be the same distance from all the vertices. It has to be equidistant from all the vertices, which is why this has to be a regular polygon. If it's not a regular polygon, sometimes there is no point that is equidistant from all, 5 or 6 or 7 or however many vertices it has. The apothem, which I've also heard pronounced apothem, and I'm fine with either, although I think apothem is the correct way to pronounce it. I said apothem for years. I slip and say, one or the other. Is this segment from the center to perpendicular to this side. So this right here is your apothem. And then a central angle is an angle with its vertex at its center whose sides pass through consecutive vertices. So the central angle would be like any of these angles is a central angle. Note that because this is a regular polygon, all the central angles are going to be the same size. Also notice that the apothem, because this is an isosceles triangle, I know it looks a little bit like it's equilateral, but it is not. The apothem is going to split this side in half and split the central angle in half. So we might want to add that. The apothem divides both a central angle and a side in half. I should have just said it bisects both a central angle and a side. That would have been shorter. Nelson, you okay, buddy? If you need to stand up or move around or something, feel free. Yeah. All right, so here, notice there are 5 central angles, and it's all the way around in a circle, makes a full rotation, so each central angle is 360 divided by 5 is 72 if it's a pentagon. Every shape has a different one. After a while, you'll probably memorize a fair number of these. So if you were trying to find the area of a regular polygon where n was the number of sides and the apothem was a, and the lengths of the sides were s, what you could do is you could go, okay, this is a, and this is s, and I could find the area of this triangle, right? The area of the triangle would be 1/2 of s times a. And then I could just multiply by the number of triangles that we have, which is the same as the number of sides. There are 5 of these triangles. There are 5 sides. So that would be 1/2 of s times a times n. And if you want to memorize that as the formula, feel free to do that. I know some students that I've had in the past have used that formula. Mathematicians are like, that's too many letters, let's make it shorter. And they notice that if you take the side length times the number of sides, you get the perimeter. So they replace the s times n with perimeter and get this formula, 1/2 the apothem multiplied times the perimeter. So that's a new formula for you. And again, if you forget it, it's okay. Find the area of one triangle, multiply by how many triangles there are, you're good to go. So let's do some example problems. Find the area of a regular hexagon with sides of length 12 centimeters. So if it has 6 or less sides, I tend to make a diagram of the whole thing. If it has more than 6, I'll show you what I do on that in just a second on the next example. So all the sides are 12. I usually only label the bottom one. I usually am too lazy to put all of them are 12. And the next thing I'm going to do is I'm going to go ahead and find the measure of the central angle. It's 360 divided by 6 is 60. And then drawing the apothem, which splits the side in half, so that each of these is 6, and splits the central angle in half, so each of these is 30. So now we have a 30, 60, 90 triangle. We've got the short leg. The long leg, which is the apothem in this particular case, is then 6 square roots of 3. So the area is 1/2 the apothem times the perimeter. So it'll be half of 6 square roots of 3 times the perimeter. Well, every side is 12 and there are 6 of them. So I don't actually have to find what the perimeter is. I can substitute in an expression that gives me the perimeter instead of having to do a separate calculation. And we're just going to multiply all this together. Let's see, 3 times 72 is 216 square roots of 3 square centimeters. And this, frankly, is one of the nicer ones. So I don't want to give you all easy examples and then give you hard homework problems. So let's do an ugly one. It says find the area of a regular octagon with apothem of 7 inches. Once it gets to an octagon, I tend not to draw the whole thing because mine start to look really ugly at that point. An octagon's not terrible, but if it's a nonagon or something like that, forget it. I'm not drawing it. What I do instead is I just draw a central angle and a side with the apothem right down the middle. And to remind myself that I'm not just finding the area of a triangle, I kind of add on a couple of sides and go, yeah, there's more to this. And then I always, privately think that this looks like a 3rd grader's drawing of a Vikings helmet. So the apothem is 7. The central angle, it's always going to be nearly the first thing that you do, is going to be 360 over 8, which is 45. The apothem splits that in half, so this is 22.5 degrees. Ugh. Which means we're going to have to use trig to find our answer here. Since the apothem splits this side in half, I'm going to call this S over 2. You can call it just X or something like that. Don't call it S whatever you do. So S over 2 is opposite the 22.5. 7 is adjacent, so that's tangent. So the tangent of 22.5 is equal to S over 2 over 7. So that means that S over 2 is equal to 7 tangent of 22.5. Multiplying both sides by 2, S is 14 tangent of 22.5. So at this point, I'm ready to find the area. It's 1/2 the apothem times the perimeter. So it'll be half times 7 times, to get the perimeter, I need to multiply the length of one side by 8, because there are 8 sides. So this would be 8 times 14 tangent of 22.5. At that point, you grab a calculator and go, okay, let's put all that in. So 0.5 times 7 times 8 times 14 times the tangent of 22.5. Bada boom, bada bing. It didn't tell me what to round it to, so I'm just going to round it to one decimal place. It's 162.4 square inches. Oh, hang on a second. Yeah, wanted to make sure the mode was right on this. So that's regular polygons. So something you haven't done before to something you've done a ton of before, and that's circles. A circle is, I left off a word here, that should be the. A circle is the locus of points, that's a group of something, is a locus. The locus of points in a plane that are at a fixed distance, called the radius, from a fixed point, called the center. So that's nothing new to you. You know what a circle is, you know what a radius is, you know what the center is. Now, what you may not know is that when you name a circle, it's named by this symbol, which looks like an O with a dot in it, and its center. So circle P is the name of this circle. It has radii, PA, PB, and PC. And the diameter is AC. Notice the diameter is twice as long as the radius. Again, none of that should be new to you. In any circle, the ratio of the circumference to its diameter, so circumference divided by diameter, is the irrational number pi. It's approximately 3.14. If you want to get longer, it's approximately 3.1415926. Now, that's all the decimal places that I know.
265.
Is it?
That's all the decimal, I think so.
I don't know.
That's all I know.
I only remember the 26 because that's my daughter's birthday is June 26th. You have to have some way to remember things like that.
International Pi Day was.
Last Friday.
Yes.
Yeah, because it was March 14th. Unfortunately, we're almost never in school on Pi Day. So the circumference of a circle is pi times the diameter, or the circumference is equal to 2 times pi times the radius. Same thing. And the area of a circle is given by pi times the radius squared. Hopefully in your either 7th or 8th grade math class, they talked about why that is. If they didn't, let me know and I'll show you, but not today. We don't have time. We might, but I don't think we do. So here, let's find each measurement, give answers in terms of pi. So here, let's find the area of circle K. Now the area is pi times the radius squared. So it'll be pi times 6 squared is 36 pi square inches. By the way, occasionally students are like, do you want me to give an exact answer? And my answer to that is, I just did. This is an exact answer. Any decimal you give is an approximation, no matter how many decimals you decide to write out. And then here, the circumference of a circle with an area of 25 square meters. So we start with the area because that's what they gave us. So if the area is 25, in order to solve this for the radius, we'll need to divide by pi first. So that's 25 over pi is equal to r squared. Take the square root of both sides. The square root of 25 is 5. The square root of pi is, well, the square root of pi. So the radius is the spectacularly ugly 5 over the square root of pi. Then the circumference is 2 times pi times the radius. So it'll be 2 times pi times 5 over the square root of pi. So that's 10 pi over the square root of pi. And pi divided by the square root of pi is the square root of pi. And my units will be meters. Yes, ma'am?
For the radius, I thought you couldn't have a square root on the bottom.
It's not my final answer.
Oh, okay.
So yeah, I kind of knew that it was going to work out. You could take the time to rationalize that and it would come out the same way. If you rationalize it, what you get is the radius is 5 square root of pi over pi. And then when you multiply it over here, the pi's just cancel and you end up with this answer. Good question. Are there any other questions?